Okay, I want you to imagine the absolute visceral pain of a production null pointer exception. Now picture that exact same error firing off 200 noisy, identical pings in your team's main Slack channel in the span of just 10 minutes. Honestly, it's the ultimate recipe for alert fatigue. It's exactly how critical system failures just morph into background noise that we all eventually learn to mute, ignore, and completely tune out.
We all know the status quo, right? Those massive, raw, unreadable Sentry webhook JSON dumps that just absolutely clutter up your workspace. They're bloated with redundant metadata, irrelevant cookies, and these deeply nested context objects that nobody can read on a phone anyway. Raw Sentry dumps in Slack are just noise. But the end state we actually want? A single, beautiful, actionable Slack block kit summary? Let's make that noise readable with AI.
So, let's dive right into this. Welcome to this fast-paced, hands-on explainer. Today, we're building a lightweight, highly intelligent observability pipeline completely from scratch. We are taking back our Slack channels and building a custom Slack bot that summarizes Sentry alerts using the Claude API. And we're going to do the whole shebang in about 20 minutes. To get us there, we'll quickly tackle 5 steps. We'll silence the alert noise, set up our Slack bot, catch those Sentry webhooks locally, apply some Claude API summarization magic, and finally output beautiful block kit alerts. Let's get to work.
Step 1. Silencing the alert noise and breaking down the architecture.
The absolutely crucial point here is understanding our data flow. Step 1. An event-driven issue alert in Sentry triggers a webhook. Step 2. Our lightweight local Node.js receiver catches that massive raw JSON payload. Step 3. We hand a pruned version of that payload over to Anthropic's Claude 3.5 Haiku, acting as our intelligent log analyst to figure out the root cause. And Step 4. Our Node app takes that concise summary and posts a clean block kit alert to Slack. It's a beautifully decoupled, reactive machine. Moving to Step 2, setting up the Slack bot and creating the workspace app. First things first, head over to api.slack.com and create a brand new app from scratch. There's a very specific permission we need here. Under OAuth and permissions, you absolutely must add the chat write bot token scope. Without it, your bot can't speak. Once you've added that, install the app to your target workspace and grab your OAuth bot token. You'll recognize it right away because it always starts with those classic letters XOXB-. Keep that token somewhere safe. Step 3. Catching those Sentry webhooks with our Node.js and ngrok receiver. If we zoom in on the code, it's just a dead simple Node.js express route. This exact block of code is basically the catcher's mitt that sits and listens for incoming HTTP post requests. So when Sentry fires an alert, rec.body is going to contain that massive raw JSON payload representing the exception. Now you might be wondering, how on earth does Sentry, out there on the public internet, reach your local Express server running on port 3000? Well, you just pop open your terminal and run ngrok http 3000. This instantly spins up a secure, temporary, public URL that forwards requests directly to your local dev environment. You literally just paste this ngrok URL straight into your Sentry webhook integration settings. A super quick, pragmatic reminder here. When you inevitably move this out of local dev and into production, you must verify the webhook signature. Sentry sends a cryptographic signature in the Sentry hook signature header. You use an HMAC SA256 hash combined with your client secret to verify it. But here is the golden rule, the gotcha that trips everyone up. Always use the raw, unparsed request body for the calculation, or your hashes simply won't match. This is what keeps malicious actors from spamming your shiny new bot. Step 4. Claude API summarization. Time for some intelligent log analysis. To actually turn Claude 3.5 Haiku into an elite log analyst, we have to lean on some prompt engineering best practices. First, we set a persona. We tell Claude, hey, you are a senior SRE. Second, we heavily use XML tags to clearly separate our system instructions from that messy, raw Sentry payload. Third, we enforce chain of thought reasoning by literally asking it to think step by step. And finally, to save big on token costs and keep latency lightning fast, we aggressively prune the payload. We're talking about sending only the last 5 to 10 frames of the stack trace, the exact place where the failure actually occurred. So the exact prompt string ends up looking something like this. Notice how incredibly direct we are being. We pass the exception values and stack trace frames and explicitly demand that Claude processes its logic inside specific thinking tags before it ever outputs the final, concise root cause summary.
This structure is a game changer because it stops the model from jumping to hasty conclusions.
And this right here is exactly why we use Claude. We're taking 40 lines of bloated, nested JSON that's filled with irrelevant cookies and metadata, and Claude flawlessly distills it down into plain English. It tells us, database timeout at line 42. Action required, scale DB replicas. It literally translates machine noise into human intelligence.
Which brings us to step 5, formatting the final message into beautiful block kit alerts.
If you haven't used it, Slack's block kit relies on a structured JSON schema to build interactive UIs. We're going to organize our alert precisely like this. We start with a header block for a high-contrast severity title, then a section block to create a neat 2-column grid showing the affected service and the environment. Below that, a context block where we inject Claude's root cause summary. And finally, an actions block featuring a direct, clickable button linking right back to the original Sentry issue so you can dive into deep debugging. And here is the final crucial line of code that marries everything together. Using the official Slack SDK and that XOXB-OAuth token we grabbed earlier, we simply call chat.postMessage. We pass in our target channel ID and hand it our newly minted formatted blocks array.
And there it is, total victory over alert fatigue. If that real-world scenario we talked about actually hits, say a production null pointer exception fires 200 times in 10 minutes, our lightweight Node webhook receiver can now group those payloads, pass a single sample up to Claude, and send just one clean, beautifully summarized block kit message to your team. We have officially replaced raw JSON spam with actionable intelligence.
We've completely transformed how we handle Sentry errors today, but honestly, this architectural pattern doesn't stop here. I want you to think about your entire stack for a second. What other noisy, data-heavy systems are currently causing alert fatigue in your workspace right now? What else can Claude summarize for you today? Keep building, keep experimenting, and thanks for joining this explainer.